Welcome to the session number 4 of hydrology and irrigation once again. Next, in the last class we have just given the introduction about the water requirement of the crops. How much of what is the meaning of the water requirement of the crops. In this further discussion, various impurities of irrigations which takes of water unfit for irrigations are. In the last class we discussed about which type of irrigation is not water is not suitable for our crops, right? So what are the impurities? Just a gist of this one is sediment concentration of water, total concentration of salts in water, TDS of the water. These are the factors which influence the irrigation water, for which type of the soil, which type of the water is suitable, or which of the crop is suitable, is it not? Proportion of sodium ions to other concentrations, concentration of potential toxic elements present in water, bicarbonates of calcium and magnesium present in that water, bacterial contaminations of the water in that irrigation water, I mean to say, effect of impure water on irrigation. These are all the factors which influences on the requirement of the irrigation. That means suitability of the irrigation. Water requirement of the, once again continue, sediment present in that, how much of the silt present in that water. Fine sediment increases the soil fertility, you know it already. Sediment from eroded areas of the decreased soil fertility, because if the sediment is eroded from the land itself, next naturally the fertility of the land decreases. The land will become the barren land or unfertile, which is not suitable for our irrigation. Sediment water in canals gets clogged. Concentration of soluble salts is also plays a major role for the suitability of water for irrigation or requirement of the water. Soil grains breakdowns and soil becomes sticky. Soil becomes plastic when wet and the crust turns dry. Concentration of toxic elements present in the water. Elements like boron, rhelium, etc. are also plays a vital role in water requirement of the crops or suitability of the crops. Boron concentration less than 0.3 ppm is good for soil. Bicarbonates of calcium and magnesium also plays an important role for the water requirement of the crops or suitability of the water. High concentration of bicarbonates precipitants in soil and causes hazardous. Bacterial contamination also, when crops irrigation with high concentration water are eaten by the bacteria. If the bacteria are more present, they even they may eat the crop itself. Functions of irrigation waters. It affects the functions of irrigation water. Water and nutrients are most important requirement of the crop. Salts of calcium, sodium, potassium and magnesium when in excess quantity causes injuries to the plant. Salts, calcium, magnesium, so and so may cause the injuries to the health of the plant itself. Prevents adequate aerations, because if these ingredients are present, naturally they will prevent the aeration. That means dissolved oxygen present in the plant. Proportion of the sodium ions to other cations. When soil contains sodium ions more than 5% of the total exchangeable ions, cation soil becomes less permeable. These are all the important, because if the soil becomes less permeable, naturally the water will not extracted by the plant easily, because it is not permeable, not easily available to the roots of the plant. Therefore, these are the important ingredients, or these are the factors which influence the water requirement or functions of the water requirement. Functions of the water irrigation waters are: it acts as solvent for nutrients and nutrients carries. Functions of irrigation water. Look at this one. Functions of irrigation waters are what are the functions that has to be played by the irrigation water for the plants? It acts as a solvent for nutrients and nutrients carries. That means It is a media. Water is a media for the solvents of the nutrient. Directly the water will not be absorbed by the plant itself. It acts as a media, or it acts as a that is a part that which dissolves the nutrients in it. Therefore, that nutrients can be extracted by the plant. Directly water, pure water will not extract by the plant. The water acts as a new solvent for the nutrients. Then nutrient will be extracted by the plants. Is it not? Irrigation water supplies moisture which is essential for the life of the bacterial for the plant growth. That's also important. Whenever there is a bacteria present in the soil, definitely bacteria requires water for its survival. So irrigation water plays that role. That means it will supply the water to the bacteria which is useful for the plants, which are the, I think you might have heard rhizobium bacteria, which are very helpful to the plants of the plants for the growth. Is it not? So this acts the moisture which is essential for life of the bacteria itself. The moisture supplied by the water helps in chemical reactions within the plant for its growth. Is it not? That chemical reactions are definitely the water will act as a media. Salt in water reacts with water, producing nourishing food products for the crop. The soil cools and soil and atmosphere creating healthy environment for growth of the plant. Controlled water supply will dilute salts in soil and definitely help for the plant growth. Softens the tillage pan. Tillage pan ಅಂದ್ರೆ what is the meaning of the tillage pan? Tillage pan is nothing but that is the ditch in which you are growing the plant. That plant will get softened because of the presence in the water. Otherwise, for tilling means that is the flowing, or the agriculture activities will, if it is the land is hard, we cannot go for the agricultural activities. If you are going to go for agricultural activities, the land should be softened. By supplying the water, naturally the land will be softened and the tillage activities may be taken place easily. Is it not? Definitions used in water requirement of the crops. Very important definitions are there. Number one is crop period. Look at the definitions. Crop period. It is time taken by crop from sowing to harvesting. Crop period. Crop period is nothing but the time required for crop from sowing to harvesting. It is a period in which, or period in days, here in which the plants is from the period of sowing to the harvesting. That's called as crop period. What is telling it is a time taken, or it is a days taken by the crop from sowing to harvesting. Sowing from the seeds, the day of sowing to the seeds on the land, on the field, on the farm, then till the end of the harvesting, the day of the harvesting, day of the cutoff is called as crop period. Base period, very important. Base period. It is a period during which water is supplied to the crops. Is it not? Base period is different from the crop period. Crop period is sowing to the harvesting. Base period is nothing but the day of entering the water, or day of supplying the water to the end of the supply of the water. End of the supply of the water to the plant. At the end of the supply of the water, so the crop will once again survive and it will give yield. That's called as base period. Is it not? The supply of the water, the day of the supply of the water from the day of the end of the supply of the water is for nothing but the base period. Base period is the period between first watering and the last watering. It is other definition of this base period. We may define so many things like this way. First watering to last watering, or the period from which the day of water is supplied to the plant, is all the different definitions of the base period. It is strictly slightly less than the crop period denoted by B. Usually crop period is denoted by capital B. Base period is definitely less than the crop period, because the watering is naturally the day of watering is days of watering is less than the day of sowing and harvesting. Next, crop depth. The first water to crop is called core watering, and the depth is called as core depth. Very important. What he is telling is the the first water crop is called as core watering. That means, look at this. Once you core water means first watering itself, you are going to call it as a core water, and the depth of the water supplying to the plant during the first watering is called as core depth. Very important. How much of water you are going to supply at the first period or first day of watering to the plant after sowing the seeds is called as core depth, and the period for which, for example, I think you might have heard that for germination of the plants, after sowing the plants, immediately 2 or 3 frequency of irrigation is more, number of days of the frequency is less rather than the later period, because the plants will get more and more germination, more and more water required by the plant for its germination or for the growth. In that period, water supply is more and frequency is also more. That's why it is called as core depth and core water. Core period. The portion of the base period in which core watering is needed is called as core period. How much of the period is required for the germination of the plant and the frequency of the watering is called as core depth as well as the core period. Once the plant's growth to the higher level or to the raises to the healthy plant, then naturally the watering is reduced, frequency of watering is reduced, right? So that is called as normal base period. It is a part of the base period. Core period is nothing but a part of the base period itself. Got the idea? Next, outlet factor, duty at the outlet of the canal. Outlet factor means duty of the outlet of the canal. That means, duty means what? Duty means D is equal to A by Q. A by Q. Area A is A, nothing but area of the I cut or H cut are common. A by Q. Q is the discharge. For what? For example, definition of the duty is area divided by discharge. For 1 cubic of the discharge, how much area you are irrigating? For 1 cubic of the discharge, 1 cubic meter cube per second of the discharge, how much of area is irrigated is nothing but a duty of irrigation water. Got the idea? Duty is nothing but A by Q. A by Q. A is in hectares, Q is in meter cube per second. Or discharge. Whether may be a Q6 or Qmax or whatever may be the discharge. That is the outlet factor, means duty of the water at the outlet of the canal. Duty is always definite. Very important definition is you should remember it. Duty. We will discuss in the next period also subsequently a detailed definition of the duty, and you will come across the water requirement. Definitions used in water requirement of continued duties. Nothing. Look at the duty. Definition of the duty. So many definitions are there. Out of important definitions are: it is a relation between volume of water and area of the crop brought to the maturity. In other words, it is a relation between the volume of water. Volume of water means A by Q anta ಹೇಳಿದೆ ನಿಮಗೆ. A by Q. A is nothing but area, Q is nothing but discharge. Discharge may be in terms of volume also. Volume also meter cube per second or meter cube itself. Right? Volume of water and area of the crop A brought to the maturity. Or once again duty. Duty of water is defined as number of hectares. Number of hectares means 1 hectare, 2 hectares, 3 hectares brought to maturity by constant supply of water throughout the base period. That means constant, how much of the areas you are going to irrigate from 1 cumex of water is nothing but duty expressed in hectare per cumex. A by Q. A is nothing but hectares, Q is nothing but discharge. Discharge is nothing but unit of the discharge is cumex or meter cube per second. Hectare maybe also you can do in terms of acres or meter square, is it not? Hectare means 100 meter by 100 meter is nothing but 1 hectare. 100 meter by 100 meter means 1 hectare, is it not? So 100 meter by 100 meter divided by meter cube per second is nothing but the duty of unit of the duty. So time factor, next definition, important definition, time factor. It is a relation. It is a days of canal. It is a days of canal has actually run to the number of days irrigation period. No delay. This is the time factor is nothing but how many days actually canal you are going to run. How many days the water is flowing in the canal is to the number of days of irrigation period. Irrigation period. For example, how many days canal is running? For example, your duty period, the duty of the period. Base period of the crop is 120 days. 120 days. Out of 120 days, how many days the canal is running, how many days the discharge is available in the canal, how many days the water is available in the canal is nothing but time factor. The availability of water in the canal divided by the number of the base period, number of days how actually the water required by the plant. That's called as time factor. Next, delta. The definition is delta. Delta is very important definition. Duty delta. What we just gist of this definition: crop period, base period, crop core depth, core period, outlet factor, duty, time factor, and next one is the delta. Very important definition. Delta is nothing but, I think you used to look at this. Delta is nothing but depth of water supplied to the plant. That means depth in centimeters. Always usually the practicing engineers are measuring the delta in terms of centimeters. How many centimeters is required for the plant for its growth? That's called as depth. That means delta. Each crop requires certain quantity of the water at regular intervals of time throughout the crop period. If this total quantity of water is made to stand without any losses on an area, then there will be a thick layer of the water standing on that land. The depth of water layer is known as delta for the crop. What the definition, gist of the definition or the overall meaning of the definition is that, for example, you are supplying the water to the plants, you are supplying the water to the crops from the base period to the harvesting period. The total number of the frequency, for example, in the first frequency 10 centimeter of the water is supplied to the plant, in the subsequent frequency 5 centimeter, in subsequent frequency irrigation 2 centimeter. That summation of all the depth of the water supplied to the particular crop is nothing but the delta. The summation of the crop, summation of the water, summation of the depth, I mean to say. That means the depth of water means, depth of the delta means summation of the water supplied throughout the period. That is called as delta. Delta always usually measured as, because it is summation. Depth means, what we are discussing here is depth means centimeters. So depth is summation of the depth is also once again the centimeters. Is it not? So the definition of depth, the delta, is it clear? Yes? Okay. Once again the delta means it is a summation of the depth of the water supplied to the plant for the individual watering since from the core period to the end of the period, or throughout the base period. Say for example, in the base period of 120 days, a number of the frequencies or number of watering may be 15. Each watering may be 10, 20, 12 centimeters of depth is there. So summation of all this will give the definitely the delta of that crop. Right? Delta of that crop. Depth of watering multiplied number of, then what he is telling is the equation for that. Simple equation. Depth of delta is equal to depth of each watering multiplied by number of waterings, or summation of each of the waterings. Is it not? Next one, capacity factor. It is a ratio of mean supply discharge to the full supply of the canal. Capacity factor. Capacity factor is an important play for the water managers or engineers who are maintaining the canals, or who are in charge of the canal system. Capacity factor means it is a ratio of the mean supply to the full supply level. FSL level. That means, because this is an important factor, whether we are running the canal in the full capacity, or whether the canal has to be run or encroach the freeboard. Is it not? Whether the canal will spilling over it, that's a very important factor. So that means it is a ratio between the mean supply to the full supply level. So in some cases, full supply level may be above the mean supply level, or in some cases our requirement may be below the FSL. Is it not? In some cases it is above the FSL, in some cases it is below the FSL. During the initial stages it may be below the FSL, and after when the crops comes to the maturity or end of this yield, then water supply may not be required that much. In that case, the canal may not be supplied fully to the higher discharge. In that case, the supply may be less than the FSL. That's called as capacity factor. Cubic day. Next one is cubic day. Quantity of water flowing for one day at rate of cubics is called as cubic day. What is very different simple definition? That for the period of 24 hours, how much of water is supplied to the plant or how much of water is let into the canal is called as cubic day. These are all the terminology used by the engineers or managers who are in charge of the canal system. And you after a subsequent period also you might come across that, or once you became an irrigation engineer, you have to use this terminology later at the later stage. Paleo. Next one is paleo. Paleo in important definition also. Paleo, initial watering before sowing the crop in order to add sufficient quantity of moisture to this unsaturated zone is called as paleo. Paleo, the definition of paleo is before sowing the crops. I mean to say before sowing the seeds to the land, or before letting the seeds into the land, the irrigation is required. That means you have to supply the water to the barren land, or you have to supply the water to the dry land, so that for easing to your seeds, some irrigation is required or some water supply is required to soften the land. That irrigation is called as polio or paleo. Paleo, before sowing the crops, that will not come into a base period, that will not come into a core period. That is not irrigation, the pre-irrigation you may say. Pre-irrigation before the sowing the crops. That's called as, terminology is called as paleo. Paleo means because in order to make the land saturated, so that you are for easy sowing the seeds. If the land is hardened day by day because of this irrigation land, naturally the land will get hardened. Is it not? Once you start sowing, it may not, the seeds may not be distributed properly. In such cases, pre-irrigation is required. That irrigation is called as paleo. Next, root zone depth. Root zone depth. That means depth of the root below the surface of the land. That means that's because this is considered, you may consider important or may not be important, because how much of this depth of the root is there, then can I supply the water directly to the root or above the surface can be judged by that. Is it not? Definitely, depending upon the depth of the root are different for the different crops. For foot bearing crops, depth may be deep inside. For paddy and other crops are maybe closer to the near surface of the earth. Is it not? If you know exactly the average depth of the root zone, naturally how much of the water is required, that is important for the frequency of irrigation. That is required for frequency of irrigation. I think in the next subsequent classes you will come across the one important formula wherein which frequency of irrigation can be calculated purely based on depth of the soil, the depth of the root zone and the saturation of the soil. Is it not? Based on that for that purpose, depth of the root zone is also required for your things. Maximum depth of the soil in which the crops spread their root system and desire water from the soil is nothing but the root zone depth. Hydroscopic water. Important. Hydroscopic water means the water available for extraction for the plant. That is called as hydroscopic. Is it not? Some of the water you may not be, it is not at all possible for the extract itself. Is it not? Hydroscopic water means it is a water can be extracted by the roots of the plants for its growth. That's called as, that's useful water for us. Useful water, that's called as a hydroscopic. It is the moisture content absorbed by or over-dried soil sample from atmosphere. This water is not capable of moving. Is it not? Hygroscopic water. It will not disturb it will not move away from that. It is easily available for the plant growth. Gross command, this is important. Gross command area and GCA, ICA. GCA, ICA, CCA. GCA means gross command area, ICA means irrigable command area, CCA means cultivable command area. There are three important definitions here. Very important for your discharge calculation or design purposes. Okay. We will discuss this definition in the next subsequent classes in detail by doing this. But anyhow, this is the definitions of important definition we are discussing means just I will give the broad definition of the GCICA. Gross command area means the total area which can be irrigated economically from irrigation project is known as GCA. Total area, notice, look at this. Total area means the command area which may be includes uncommand area also. That means not irrigable area also. Grass, it is a grass. Grass means whole. Whole means it may be includes the roads, it may be include buildings, it may be including park, it may be a graveyard, it may be a village, it may be a rehabilitated area, which is coming in that area is nothing but GCA. But it is not possible for us to cultivate that land. It is not possible for us to cultivate the graveyard. It is not possible for us to go for the roads. We are not at all growing any crops on the roads. We are not growing crops on the villages, top of the villages, or that means top of the roofs. Is it not? So even though it is a command area, even it is a coming under command area, it is not coming. It is not. We are not growing the plants in that. We are not growing the. We are not coming. We are not growing any plants, or we are not taking into the area for irrigation. That is grass command area. Cultivable command area, or ICA or GCA. ICA or GCA. ICA or GCA once again same. ICA means irrigable command area. Out of this command area, which is how much of the land I can irrigate, excluding all the areas which may be of land, which may be of garden, anything. Is it not villages, other things? Excluding of that, which is how much of area I can irrigate. How much area I can consider for the irrigation land for our design purpose is known as cultivable command area or irrigable command area. That much area I can, for example, 1000 hectares of land is available for us for this project. Out of 1000 hectares, only I can irrigate 70 to 80% of the land. 20% land may be of roads, of park, graveyards, villages, gardens, so and so forth, roads and so forth, and forest area also so and so forth. It's not at all possible. Out of usually the practicing engineers, design engineers are taking into consideration of 80% of the grass area to the 80% of the grass area for the cultivable command area. Out of 80%, we can 80% can be irrigated from 100% of 100 hectares, right? So, the rough idea is that 80% can be considered by ICA, right? Is it not? The total area which can be irrigated economically from irrigation project is known as GCA, and the entire GCA is not irrigable because it is indicated uncultivable land such as roads, villages, ponds, graveyards, so and so forth. Is it not? Which is not at all possible for us to irrigation. Yes. Last one is availability of the soil. What we are discussing, the availability of the soil for the water. Right? This is the definition. Still we have definition continued in this class, right? Definition hydroscopic water anta ಹೇಳಿದ್ವಿ ನಾವು, capillary water anta ಹೇಳಿದ್ವಿ, gravitational water anta ಹೇಳ್ತಾ ಇದೀವಿ ಈಗ. We are discussing that. Is it not? Capillary water, hydroscopic water we are discussing just now. Capillary water. This is a part in excess of the hydroscopic water which exists in pore spaces of soil. This is available for the plant growth. Capillary water can be easily extracted by the plant for its healthy growth. Capillary means it naturally will coming out from the soil, and it is easily available for the root zone to extract. Is it not? So that is called as capillary water. Next, gravitational water. Gravitational is the part of the excess water which will remove out of the soil under the action of the gravity and possesses down to ground. Or the gravitational water means it is not easily possible for the plant to extract. It is always going towards away from the root zone. So you may not consider that is the part of the water which is not available for our plant. No, really, what this is the thing means, in supply water, the supplied water may be of 3 types: hygroscopic water, capillary water, and gravitational water. Is it not? Only for capillary water and hygroscopic water, you can expect the water from us. You can expect the water for the plant's growth. Is it not? Gravitational water you have to leave. For example, 100 liters of water is supplied to the plant. Out of 100 liters, you may consider only for 70 to 80 liters of the water may be extracted by the plant. The remaining water is go out of the root zone of the plant itself. So is it not? So this is the things what we have discussed so far. In the subsequent classes, detailed discussion about the water requirement of the crops and how the canals are designed, and basic idea behind cropping patterns, season of the crops, in which season which crop is grown. We will discuss in the next class, friends. Okay, thank you. Thank you.